So, we will look at different instruments briefly, right. So, a multimeter, as the name indicates, it can measure number of things. Typically, it is used to measure voltage, current, resistance. It can also be used to measure capacitance, the power level, frequency and so on. So, you will typically see, so this is a digital multimeter. Okay. You can see that the readout is digital. Okay. The readout is digital. And you can see that there is an area for measurement of current. Okay. There is an area for measurement of voltage, there is an area for measurement of ohms or the resistance, frequency, capacitance. So, you can set this this bar, okay, to measure any one of these things. You can say I want to use it as a ohm meter, or I want to measure current in amperes or current in milliamperes, in volts or millivolts. You can measure the frequency, capacitance. You may be able to measure the H parameters, temperature, etc., etc. Okay. So, the more things you can measure, you can expect that the equipment will be that much more expensive. Okay. And it also shows that this can go up to 20 amperes. Okay, there is a maximum current that it can measure. Right, if you pass more than that, you may damage the meter. Right. So, the multimeter simulator, let me see, if you actually go to a lab, right, then you may be able to use the multimeter, right. That is the best thing to do, right. But if you are not having access to such a lab, then you can still use some simulators, etc. So, there is one workhorse. So, let me try and show you that. Okay. So, it sort of looks like this. It has a so, you can use the multimeter to measure. It is a virtual multimeter, right. So, you can say I want to measure the battery or something like that, right. So, these are the two probes. Okay. So, you can sort of insert the probe. Suppose I want to measure the uh, okay, and you want to measure it between these 2 points. Okay. So, you can use your mouse to move this guy. Okay, this is explained in that website which I showed you. So, just look for workhorse, right, and you can use the right click and move the mouse, right, and you can use the left click to move the mouse away or below, but the right click can be used to move it in this whichever direction you want. Okay. And there is a way to start this guy. Let me see. This is whether I am measuring the AC voltage or DC voltage, and you can power it on. Okay. And you can use this to measure voltage, right. So, I can say okay. So, it should have measured by now. Okay. So, actually the common port should be, this is the common port and this should be plus. Okay. Now, it will measure it as a positive. Okay. So, it is measuring the voltage as 12.6 volts. So, there is a battery, it is possibly a car battery, it has 12 volts, but the actual measurement is shown as 12.6 volts. Okay. So, you understood, right. So, you have to this common this gray one is the common or the ground, the red one is the place where you want to actually make the measurement. If you interchange them, you will get a negative value. You will get the negative value like this. Okay. So, you get a negative. Okay. So, you can also measure, there are many experiments like this. Okay. So, here is a battery, it is the same 12 volt battery I think, and then there is some resistance, and it is there is a bulb here, right, and this is a circuit. Okay. This battery can send a current through the bulb, right. You can turn it on or off. Okay. So, right now it is on, that means the current is actually going to get dissipated here. So, we have to measure, let us say, the voltage across this resistance or across this bulb or something like that. So, do the same thing, bring this guy over here and bring this guy over here. Okay. And then maybe measure this value here, and maybe measure this over here. So, I am using my right click to sort of adjust this guy. Okay. So, we are using DC measurement, and we can turn on the power. Okay. So, we have to adjust this correctly. So, it is when I set the voltage to the 20 volt range, that means the maximum voltage that I can measure is the 20 volts. Then I can see that there is a 3 volt current across the I am sorry 3 volt across the LED. Okay. If I move this guy, okay, So, across the resistance I see 9 volts. Okay. So, the 12-volt battery, 3 volts across the resistance, right, and I am sorry, 3 volts across the LED and 9 volts across the resistance, right. So, you get to see the voltage across each of okay. So, that is the experiment. Okay. Then you can measure the resistor. Okay. So, once again put this guy here, put this guy here. Okay. Choose DC maybe, and this time you are measuring the okay. So, maybe we show here. Just a second. Okay. So, when we are in this range, so in the 200 ohm range, it is showing me the total value is 100 ohms. Okay. So, 100 ohms is the resistor value. Okay. So, this is another experiment. So, in the actual lab, you can take a known value of the resistor. Okay. You can maybe borrow a 100 ohm resistor from the lab assistant and make the measurement directly, right. But this experiment helps you to do these things before going to the lab. So, you are better prepared, and if you never have access to a lab, it still helps you to understand. Okay. So, there are many other experiments, I will not go through all of them. I hope you got an idea. Okay. The main thing to understand is this is the negative, so you should put it in the common port. See, it says common here, right, and then this is the the positive, right. Turn on the DC. Okay. There is AC and DC measurement. So, if you are measuring the AC, then it should be set here. If you are measuring DC, you should set it here, and then drag this guy with the left mouse wherever you want, right. This guy should go here. Use the left mouse button to move things. Oh, just a second. There is some bug in this simulator, maybe not able to move this guy around. Use the left mouse button to move, and then the right mouse button. Okay. When you use the right mouse button and keep it pressed and then move the mouse, it moves. Okay. You have to practice this a little bit. Okay. Then there is some problem in this. For some reason, I am not able to move this guy. Okay, you please practice. I am not able to move this properly. one last trial. I do not know what exactly is wrong, but sometimes it does not move. Okay. This is the point you have to understand. You have to then DC, power it on, and you have to adjust this guy so that it measures the value. You have to adjust this. This is a voltage. See, this is the voltage. This is the current. Okay, and this is the resistance. So, when you are in the right range, okay, you should, we know that this value is actually somewhere at around 12.6 volts. So, it should point to this 20 volts range. That means the maximum voltage that I can measure is 20. If you put it here, here also it is showing as 12.6 volts. Okay. But if you put it here, you can see the accuracy went away. Okay. This is meant for measuring 600 volts or something like that. So, the resistance you are measuring, the voltage you are measuring is quite small. So, it may show it as 12 volts. So, okay. So, I want you to try this out. Okay. So, we saw that using the multimeter simulator, we can understand how to use the multimeter to measure voltage, current, resistance. It can also be used to measure capacitance and frequency, but I do not think that particular website has any measurements, experiments for capacitance and frequency. So, whatever you just saw is an example of a virtual lab. Okay. So, a virtual lab means you do not actually have the equipment, but you can use an online simulation to sort of understand how the equipment actually works. Okay. It can be used for training people. So, what happened during COVID was many people who joined companies were actually not able to go to the labs. Okay. They had to be still trained. So, having tools like this will be very helpful in such a situation where you can still understand how the equipment looks like, what are the controls, etc. Right. So, more sophisticated simulators are available from vendors, but this one is a free simulator for a multimeter. Okay. Similarly, there is a to understand how to use the oscilloscope, this pzdsp.com elab is a good one. So, let me quickly show you. Okay. So, you can see that it shows a how a oscilloscope might look like. Okay. There may be different kinds of oscilloscopes, right. So, this is one example, right. Here is a signal generator. Okay. That is another tool that you may end up using in the lab. The signal generator can generate 3 different kinds of waveforms. So, you can either generate sinusoidal waveforms or triangular waveforms or rectangular waveforms. So, right now it is set to sinusoidal. If you move this, you can see it generates a triangular waveform, and if you move this, you can see it generates a rectangular waveform. Okay, it is a square waveform, right. You can use this to select the frequency at which the signal operates. So, this is a high frequency signal, somewhat low frequency, okay, even lower. Okay. So, finally 1 hertz. Okay. So, you can see that the 1 hertz signal you cannot see it in a stable way, right. So, you will have to do something to stabilize that waveform. Okay. If it is a 10 hertz waveform, you can see that it is able to. You can measure the, you can change the, see this is this waveform, the DC value is 0. What it means is the average offset is 0. Okay. So, that is the DC offset. Okay. If you change it, then you can see that we added a small offset. So, as a result it shifted up. So, here we can change it, it keeps shifting up. Okay. So, now I have added about 1 volt offset. Okay. So, now it has gone up. Okay. In the same way I can reduce it. Now, I have brought it back to 0 offset. Okay. And then I can also go and move it below. I can add a negative offset. So, minus 1 volt up to minus I think it can go up to minus 5 volts and plus 5 volts. Okay, that is the. You can also change the amplitude. Okay, you can reduce the amplitude or okay. This is reducing the amplitude. This is increasing the amplitude. Right. And you can change the frequency here. Okay. So, this is increasing the frequency. So, in this I have selected a 10, that means the maximum value is 10 and I can go up to this, right. Let us see, I believe now it is about 100 hertz. Okay. So, I can, when I am in this range 10, I can go from 10 to 100 hertz, right. Whereas, if I change this guy, I can go back to multiplier of 1 and choose 100. So, now I have generated a 100 hertz, okay, and I can now generate 200 hertz, I am sorry, 120 hertz, 160 hertz, 200 hertz, 500 hertz and so on. Okay. Now, this is the oscilloscope. Okay. This is the signal generator, this is the oscilloscope, this is what you are seeing on the screen of the oscilloscope, right. You can use this control to position the your waveform. This is called vertical positioning. Okay. You can use this to change this amplitude. Okay. So, right now it is set to 2 volts per division. Okay. So, I can change this to 1 volts per division, or I can change it to 5 volts per division. So, you can make it look smaller or bigger and then multiply with this. Okay. So, this is a horizontal positioning. Right now you are not able to see that movement, okay, because it looks. You can also change the times per division. Okay. So, if I change this guy, right, you can see that it is able to clearly display a what is the frequency now? I have chosen 100 here and 5 here. So, 500 hertz frequency, okay, 500 hertz frequency. So, let us use the horizontal positioning here, okay, and let us use the vertical positioning here a little bit. So, there is a little bit of, okay, let me also change this guy. Okay. All right. So, let us see 0, let us adjust a little bit. So, it goes from here 1 division, 2 divisions, 3 divisions and maybe 3.8 divisions. Okay. So, each division represents 2 volts. Okay. So, you have to multiply 2 with whatever you saw 3.8 or something like that. So, 3.8 peak to peak multiplied by 2. So, it is approximately 7.6 volts is the amplitude. Okay. So, we can just check, let me keep it at 4 volts actually, right, it is saying 4 volts here. So, 1, 2, 3, 4. So, this is actually saying 8 volts. So, the amplitude according to this guy is 4 volts and according to this guy it is 2 volts per division, 4 means 8 volts. So, where is the, so I have adjusted the amplitude to be 8 volts peak to peak, right. Let me adjust the vertical position. Okay. So, 1, 2, 3, 4, 5, 6, 7, 8. So, 8 divisions. It is showing 2 here, which is, there is some small adjustment required. It is actually right now at 1 volts per division. So, because we saw, right. So, 8 volts peak to peak, right, or maybe it is not peak to peak, maybe it is only the half the value of peak to peak, that is possibly what it is. Yeah, I think they have given this value. So, if it is 4 volts, I suspect it is 1, 2, 3, 4. It is showing 4 volts, 4 divisions here, but actually it should be read as 2 divisions. Okay, it is only the positive swing that we have to take. So, 2 multiplied by 2 is 4 volts. So, then it works correctly. Okay. So, I hope you understood the controls that are there. You can adjust the volts per division. So, if you make that higher, it will shrink, okay, because 1 volt is now 5 volts. One division or one one division is actually 5 volts now. Okay. So, if you want a larger waveform, you can try to go the other way around. Okay. In the same way, if you want this to sort of get spread out, right. So, you can use this control. Okay. So, if you reduce the time per division, it will look like a more spread out waveform, right. Whereas, if you go the other way around, it will okay. And we saw one 1 hertz waveform, right. We were not able to. So, let us see if we can trigger this a little bit. See, the idea is to stabilize this guy. I am not able to stabilize a 1 hertz waveform. If I increase it to this is actually 5 hertz waveform. It's a 5 hertz waveform. See, this trigger value, if I move it up, you can see it stabilizes. Okay. See, if I bring down the trigger value, it becomes unstable. See, whereas if I move up the trigger value, it stabilizes. Okay. So, you have to use this property to stabilize the 1 hertz waveform. Okay. So, higher frequencies are easy to stabilize, but if it is a very low frequency waveform, it may appear to be unstable. So, you have to adjust the trigger value, you can adjust the times per division. Okay. So, verify, see, this is a, according to the signal generator, it's in this 1 hertz range, right, and the frequency multiplier is 10. So, what we are seeing is a 10 hertz waveform. Okay. So, here you can see that it is one particular waveform is going from about 2 volts. Okay. So, 2 volts multiplied by 50 milliseconds, right, that is 100 milliseconds. Okay. So, you can see that that also corresponds to the same frequency. Okay. So, 100 milliseconds, right, is 100 multiplied by 10 to the power minus 3 or 1/10. So, 1/10 of a second, or you can say it is 10 hertz. Okay. So, that is how you understand the. Okay. I think you can use this to stop the sound. If you do not like to see the sound, I think you can avoid that. Okay. And I think you can use this oscilloscope to not only measure the output of the signal generator. I think there are some, maybe not this one, right. There are other websites where you can provide your own signal. Okay, sometimes you get an audio signal from the um, music, from the speaker, etc., from the microphone. You may be able to measure the voltage on the oscilloscope. Okay, I think this particular one may not allow that. Okay. All right. So basically, we have gone through at least two measurement instruments. One is signal generator, the other is the oscilloscope, and the third one was the multimeter. Multimeter can be used to measure voltages, currents, and all right. So we'll take a we'll recap whatever we saw in the class today. We talked about the error in measurement. We talked about how error measurements can lead to incorrect conclusions about the chip. You may end up classifying a good chip as a bad one or a bad chip as a good one. So measurements must be you have to do it very carefully. So if you are a characterization engineer, right, you may have received a number of silicon samples, and you may be interested in measuring the output frequency, output amplitude, etc., for different settings. So that is where your ability to measure things correctly, both accurately and precisely, comes into picture. Okay, so you have to spend time getting used to various measurement equipment. Okay, there are many other measurement equipment, right? Especially if you are using RF measurements. Okay, RF stands for radio frequency. So in a number of automotive applications, for example, they may use radar, okay, millimeter wave radar, and there maybe you are interested in measuring RF voltages and RF currents, etc. So in such situations, you may want to use what is called as a VNA, vector network analyzer. So that's another equipment that may be present in some labs, right, where there is work going on in the RF area. Then spectrum analyzer is another useful device, right. So there may be several other equipment in a test lab. Okay, I mentioned the most simple ones, but you may also end up using things like the spectrum analyzer, right. I could not find a demo tool for spectrum analyzer, but I will be able to tell you a little bit about what a spectrum analyzer does. Okay.